This is Geometry A, Unit 7, Lesson 3, Bisectors and Triangles. You've already seen, hopefully, the one on perpendicular bisectors. This video is on angle bisectors, so angle bisectors and triangles. Let's go ahead and follow the same outline as before. We'll remind ourselves what an angle bisector is. So if you start with an angle, you can construct its bisector, angle bisector, by placing the compass point at the vertex of the angle, that's the corner, common starting point, and drawing a circular arc that crosses both legs of the angle. And then putting your compass point at one of the intersection points, drawing an arc in the interior of the angle. We can change size right there if we want to. But then copying that same arc to the other intersector. That determines a new point through which we can draw the angle bisector. Okay, so that's a reminder of how to construct the angle bisector. So when we do that for a given triangle, this is what it looks like. Okay, so let's draw a triangle, and we're going to draw the angle bisectors. Angle bisectors of a triangle. There we go. All right. So there's no really good shortcut like there was for the perpendicular bisector. You simply need to draw an arc at each of the vertices. And I will go ahead and save a little bit of time by using the same compass setting to draw the initial arc on all three corners. All three corners. Precision is important. Okay, I'm going to start with the biggest angle here and draw an arc out here and an arc out here. Okay, here we go. And here we go. Okay. And I'm going to purposefully shorten this one because it's going to overlap quite a bit here if I don't. Okay. And just so the left and the right match. Okay. And now draw the angle bisectors. It's easy to get confused as to which intersection we need, so make sure you're careful about drawing it through the intersection that you need. One angle bisector, two angle bisector, okay, and three angle bisector, okay. And if you did it correctly, you'll notice again, just like before, they intersect at the same place. They are concurrent. So we started with angle bisectors. We discovered the angle bisectors are concurrent. We call the point of concurrency the in-center. The perpendicular bisectors form the circumcenter. These form the in-center. In-center. Okay. And what's more, if I draw the circle just right, I'm going to put my compass point right on the in-center here, and I'm going to grow my circle so it just touches one of the sides. I'm going to discover that it touches all three sides. Okay, so it's the center of the in-circle, which is an inscribed circle. You recall the perpendicular bisectors met at the circumcenter, which is the center of the circumscribed circle. That's the circle that goes around the whole triangle. This circle goes inside the triangle and is inscribed in the triangle. It just touches the edges. And as such, a circle is all points equidistant from 1. That means it is equidistant from the sides. And that goes with what we learned about angle bisectors and perpendicular bisectors last lesson. Perpendicular bisectors are equidistant from the endpoints of the line segments, in this case the corners of the triangle. Angle bisectors are equidistant from the sides of the angle, in this case the sides of the triangle. Okay. All right, so let's do this in GeoGebra as well. I've still got the other triangle here, so let's get rid of that here. So use the polygon tool to draw a triangle. Okay. And then use the construct tools to construct the angle bisector. So A, B, C, B, C, A, and C, A, B. And look at that. They do meet at a single point. Let's put a point there called the in-center. And it's a little bit tricky to draw. It's a little bit tricky to draw the in-circle here. So what I need is the perpendicular distance from the in-center to one of the sides. So I'm going to do a perpendicular line through a point not on a line. So click on D and AC. So that's perpendicular to that side. And then I'm going to put a point on the intersection there. So DE is the distance, perpendicular distance to AC. And then I'm going to draw a circle with center D that goes through E. And you'll notice it just touches all 3 corners. Okay, and let's go ahead and change the line style on this one here to minimize that. Let's just make it dashed and very thin. Well, that didn't work. Well, let's try again. Dashed and thin. Huh. It's not working. Anyway, I'm not going to worry about it. So now as I move around the triangle, what you notice, I hope, is that the triangle, the circle, is always just touching all 3 corners of the all 3 sides of the triangle. But what's more is the in-center is always inside the triangle. I can't make it go on the edge of the triangle or go outside the triangle. It's always inside because the in-circle has to be inside the triangle. Okay, so it's equidistant from the sides, and it is always inside the triangle. All right, I hope that helps.